My name is Christina Mikhailik, and I am a project manager at Footprint, as well as a team member of CLF Alberta. We are a local hub of the Carbon Leadership Forum, and we coordinate local events that empower industry professionals to radically reduce embodied carbon from buildings and infrastructure. The CLF Alberta is working closely with ENBIX, the Emissions Neutral Building Information Exchange. ENBIX launched here in December 2023 with a goal to accelerate the transition to an emissions-neutral built environment for new and existing buildings across Alberta. So ENBIX is an industry collaboration led by Alberta EcoTrust Foundation with financial support from its Climate Innovation Fund, the cities of Calgary and Edmonton, and Natural Resources Canada. ENBIX works closely with partners and industry leaders to share knowledge, build capacity, and support building and renovation practices across Alberta. Our conversation today is focused on embodied carbon, and I'd like to share the CLF Alberta website with you, clfalberta.com, as a resource for you to dive deeper into this subject. Over the last couple years, we have been doing events, and we have amazing events that are listed on our website. In particular, some of you in the audience today may be interested in Embodied Carbon 101, the webinar recording, where Anthony Pack discusses embodied carbon, a comparison of software tools, and methods to reduce embodied carbon. There are some other informative resources on this site, as well as the parent site, Carbon Leadership Forum. And so I encourage you to bookmark it and check it out after the session. So we look forward to continuing to work with ENBIX to bring embodied carbon to the forefront in Alberta. All right, here, so we have this amazing panel discussion here that is going, so I'm going to introduce our panelists, and then I'm just going to do a really quick introduction of some terms just to make sure that we have a level playing field in terms of definitions here. So we've got three amazing panelists that are with us today. I will start with Peter, who is the National Sustainability Manager with the Canadian Wood Council. Give yourself a wave. I have Stephanie Fargas, who is an Associate and Specifier at Dialogue, in the middle there. And Chi Dara, which is an assistant professor of interior design at Mount Royal University, MRU. So before we move on to the discussion a little bit further, I just wanted to provide a couple definitions, just three definitions here that you will hear just to kind of have a bit of a level playing field. So life cycle assessment. Life cycle assessment is the assessing environmental impacts associated with buildings. So this would include above and below grade structures, including materials such as concrete, rebar, structural steel, and structural wood, as well as the building envelope, which would include insulation, cladding, glazing, membranes for wall, roof assemblies, etc. The LCA then explores impacts of these products as we evaluate their contributions for different stages. So the first stage we typically see is the product stage, which takes a look at the extraction, transportation, and manufacturing for the materials that go into our buildings. This is a bit of a minimum that we would take a look at, and it is called cradle to gate. And then further to this, the emissions would be included for construction and transportation and construction activities, as well as the use stage, which includes repair and replacement of building during the building's lifespan, and as well the end of life stage, which would either include disposal or recycling, as looking at the cradle to grave. The life cycle stages that we take a look at will vary in terms of scope and what's included in those boundaries from assessment to assessment. So it's really important to be transparent or define that information that's available. Environmental product declaration is the environmental data of a product through LCA and are used to complete the whole building life cycle assessment. So these declarations kind of act like a nutrition label, where you're able to take a look at these different products and understand what their environmental impacts are. Each EPD is created with a product category rule, so that when we're taking a look at scope and boundaries, we'll be taking a look at things that are similar to allow for a proper comparison of these products. And while there are many different types of EPDs, third-party reviewed EPDs that conform to ISO 14025 are the preference. And finally, embodied carbon, it is in our name here. This is the greenhouse gases that are associated with the emissions that are associated with the life cycle stages from the building life cycle products. The embodied carbon is reported as global warming potential in kilograms of CO2 equivalent, and these emissions are separate from operational carbon that occurs during occupancy energy use. Well, excellent. Well, thank you so much for being here, panelists. This is really exciting to have this conversation here. So I kind of wanted to just start off taking a look at how people work with embodied carbon. So Stephanie, I'd love to ask you, how do you, as a design representative here, fit into the delivery of a low-carbon building project?
So I would say to achieve significant embodied carbon reductions, you need to start as early as pre-design or even responding in the request for proposals. Start establishing those baselines and understand how much of a target is reasonable within your marketplace, as well as like the typology, and to leverage tools such as like conducting a whole life cycle building analysis early on and throughout the different phases as a measurement and verification tool to understand, is your design actually meeting the targets that you're achieving, and then start identifying what materials within the marketplace allow for an opportunity for significant embodied carbon reductions.
Excellent. And how would you say when you're typically engaged on these projects for life cycle assessment?
I would recommend like a schematic design to start doing an early stage analysis and then follow through it all the way till like construction administration to do a whole building as-built LCA.
Excellent. How common are the as-built LCAs that you've seen so far?
Unfortunately, not very common, but in our firm, we really advocate for it in order for us to actually benchmark, are we meeting the targets that we're achieving, as well as some of the commitments that we've signed on to, like the SE 2050, which is geared towards structural engineers. That allows us to understand, is our current approach to structural design actually meeting the targets, as well as different commitments through like the RAIC and the AIA Materials Pledge. We're using that as a way to leverage our portfolio.
Excellent. And in terms of embodied carbon, when we see these typical assessments, they're looking mostly at the structure, above grade and below grade structure, as well as for building envelope. So Chi, I'd love to ask you a bit more. When it comes to interior fit out, something that's typically excluded from life cycle assessment, why is it important to evaluate this as part of embodied carbon analysis and LCA?
Can you hear me?
Yeah, we can hear you.
Okay. Yeah. So interior design is important piece of embodied carbon, and this is because when we conduct LCA, we usually look at structure and building envelope, right? So tenant improvements and taking over occupancy kind of happens after the schematic design stage, the construction. So sometimes those get left over during the building construction, but obviously they have their own impact. Think about it, like building structure has, most building structure like your steel, your concrete, they have up to 60 years life expectancy, right? How about the interiors? They have less than 20, 15, 10, depending, right? So what does that mean? It's this building materials and finishes will get replaced many times before the end of life of the building. So if I consider the concrete as a structure that will live to the end of life of a building, and the floors that is mostly used that may be tear off depending on the new clients that don't like it, new tenant want that to be replaced. I don't like those carpet, they look old, and they replace it every 10 years. That means I'm gonna replace those carpets, say 2 or 3 times before the end of life. And how then does this matter? It accounts for recurring carbon, right? When we look at LCA, we mostly focus on the upfront carbon, which is like initial carbon during the production stage, till transportation, till building installation. And the recurring carbon happens during the use phase of this building where, replacements of these materials, because they have low life expectancy and they get replaced as many times as possible, those get ignored, but at the overall, at the end of life of this building, they kind of ramp up a little bit, and it's something that maybe we should also bring up in discussion when we talk about embodied carbon. It's not just about the structure, the building envelope, but also looking at other materials like your furniture, the seats we're using, the lighting, the HVAC, and all those systems that get replaced more often than the building structure itself.
Absolutely, and there's also a large talk about MEP, mechanical equipment and plumbing, et cetera, being included as we go through. So I guess kind of talking about that, there's a challenge that there are items that are not being taken into account for in most LCAs. Stephanie, I'd be really interested to hear, like, what do you think is including that would be some of the significant challenges and gaps that you encounter when doing LCAs? Again, I'm sure that's a huge portion of it.
Yeah, it's quite a complex issue that we're dealing with. Depending on the tool that you use, you can get quite finite, and for us, that is a useful way to analyze our buildings. But if you're using a tool where the focus is more of a average of an industry, it's very difficult to know, are we actually making the correct material selections? And then the other issue that we have is not a lot of manufacturers, specifically like on the envelope side, have product specific EPDs. So it's very difficult for us to get an understanding of where is the marketplace at, because there's not a lot of incentivization for manufacturers, like within the federal or provincial government or even municipalities, to give money to manufacturers to go through the process of just, let's see where you're at and then start optimizing your manufacturing process. That's a big gap for us, is we don't really know the true impact of our projects because there's a lot of data gaps right now.
Absolutely. There's a lot of industry-wide EPDs that have been used over the years, which have been great to understand, an impact, but not necessarily the product specific, like you're pointing out. And Peter, we've talked about EPDs before and how essential they're going to have to be going forward for manufacturers. I'd love to hear more about your opinions on how essential they're going to be and what manufacturers need to do in order to get this kind of going.
Well, in North America, there's been a lumber EPD for about a decade now, but it's an industry-wide. It's based on operations in Southeast United States, in British Columbia, Quebec, and all across the continent. But that's not accurate enough. And I think given that the environmental product declarations and embodied carbon are going to be encompassed in the 2030 code cycle, for the embodied impact of buildings, it's going to be important for us to have the data on that. Just this past year, we completed surveying over 200 companies across the country to get regionally specific EPDs. Now, people say, well, why not site specific? Well, I think it's not so critical to have a site specific for a product like lumber, which gets sort of mixed and matched and shipped all over the continent. It's saying, hey, all of these EPDs are within this circle of impact. The outlier might be this one company here, or this one might be extremely good. And so whether you are at 37 kilograms CO2e or 38, doesn't make a big difference. It's sort of saying, okay, we know that the range of these products is in here. One of the disadvantages for wood is that the global warming potential of wood products is typically quite low. So the transportation impact is higher from a relative point of view. But it all starts with having data. And the data has to be valid, it has to be scientifically based, it has to be acceptable, and it has to be relevant. And I think one of the things that, in the Bell's curve of early adopters and laggards, I think it's pretty clear from the government that the codes for that last section will encompass embodied carbon in 2030. So the laggards can't say, well, we didn't know. So we've got 6 years to get our act together to understand what it means. I think the real challenge is it has to be intentional. We have to enshrine that in our specifications. We also have to deal with cost. That's going to be enshrined. We have to have energy performance. It has to be acceptable in the codes. So this is not simple stuff. But if we are all on the same page to say we want to reduce the embodied carbon, we need to have energy performance, and things have to be acceptable in our code cycle. Then we identify who in the value chain and who in the supply chain we have to work with.
So your call to action to manufacturers would be to get an EPD?
There should be product EPDs that are relevant to that specific location. I was asked a question earlier about local Alberta. Alberta's grid is not as low carbon as, say, Quebec or BC. But when I look at the data, the impact on the wood products it's different, but it's not so different that it means that you should ship your products from Quebec. So the transportation impact for lumber from Alberta is probably going to be will offset the difference in embodied impact from another producing area.
That's also an important reason as well to have that EPD data available, so we could actually evaluate, is it worth to transport something in if it's low carbon enough? That idea of being able to actually compare these products is supposed to be the hallmark of the EPDs, that we're able to actually compare and contrast and make selections through transparency, right?
Yeah, but EPDs, they were not designed to be compared. They were designed to give you an indication of, where can I improve my process? It's the same with LCA. They're not designed for comparison. Everybody will compare them. I think it's accepted that they will be used to compare materials, but that's not what their purpose is. The purpose is just a declaration, this is the impact of this particular material. And we're finding that the variability between operations in Alberta or BC is actually not a huge difference.
Great to know. So when we're looking at low embodied carbon products or products that are trying to reduce their embodied carbon, there's going to be some decisions that might need to be made in terms of, well, we want to have a lower embodied carbon, but maybe it comes at the expense of something aesthetic. So, Chi, I'd love for you to discuss a bit further how you might help with balancing client preferences in terms of minimizing embodied carbon while also pleasing your client, specifically from the interior fit outs portion, if you could speak to that.
Quite interesting because the client is always right? So, and it's our job to please the client just to keep money in our pockets, right? But at the same time, we also have a job to do, which is to guide the client right. And usually, how I like to approach it is like present three options, I call it, to the client and say, here are your 3 options. If you go with repurpose, right? How about we make retrofit, or we kind of tear it up and do a new thing, and making the client understand that each of those design decisions has its own level of embodied impact that follows it. So if we go to repurpose that is a very low, gives us like a low impact. Like if we decide to make a retrofit of everything, it's a medium range, right? We can take some things down, keep some, but if we decide to go for brand new, that means we're trying to get new products that we're gonna harvest this product, go through manufacturing process, and complete the life cycle of this product. And also reminding clients that embodied carbon is not like energy efficiency, when you can say, okay, now I'm having higher energy consumption. Can I turn down my heating system so I can save energy, right? Can I, reduce the AC or increase my heater? We don't have that leverage when it comes to embodied carbon, because once it's emitted, it's not you can't reverse it. So once you pull out one material, one product, you can't take it back, right? So also reminding them of that it can be reversed. Once it's done, you use it, or you find a way to reuse it. Also makes the client get more aware of that, and also give them options, like if there are other options from products that have longer, that are more durable products that could last longer, you can also recommend those for them.
Something that popped into my head when you said that is that there's no refunds on embodied carbon.
No.
Once you do it, it's done. It's in the ether now. It's been exposed. So
yeah, it's done, and that's why when we look at products these days, it's important to go beyond the aesthetics. I'm also guilty of that, right? So I want to buy things that I like, right? That I want to use, but also understanding that same product, 3 different bottled waters, it might take more to process this one and less to process that one, and that. But also believing that we all have to work together to reduce that is also like something good to look into. But of course, it's very challenging when you have clients that really know what they want and they have some things in mind they want to go for yet.
absolutely. I would love to hear your opinion, Stephanie, as well, kind of on more the full life cycle assessment of a project and how you balance clients' decisions with wanting to reduce embodied carbon from those standpoints from the whole building. Would you be able to comment further on that?
Yeah, we actually recently did that for a post-secondary client at the University of Victoria, where we approached carbon through the lens of whole life carbon, because they were concerned about value engineering and the complexity of supply chain, and whether paying a premium for low carbon 50 years from now, are we actually going to get our ROI? And so approaching it through analyzing our energy targets as it related to embodied carbon reductions, we were able to keep our budget and incorporate all the different value engineering considerations while still achieving like a 20% embodied carbon reduction on like a major renovation and addition. I thought that was like a good tool that we should start advocating for, that you can start analyzing costs into your embodied carbon decisions.
That's excellent. And in terms of concrete, I know that within the architectural sphere it may be a bit different, but is concrete something that we typically see as a instant hit that we should take a look at reducing? It seems to be a great approach to start, right?
It is, but for some reason there's still a hesitancy with like certain structural engineers of a simple change is changing out your cement type. There's still a lot of hesitation on trying new technologies, even though there's a lot of published academic papers validating it. There's just the education and an awareness that needs to happen in the construction industry that you're not going to impact the long-term durability of your concrete. And it actually doesn't cost that much in Alberta right now to achieve a 17% embodied carbon reduction with low carbon concrete. Just simply switch out your cement, and there's not a cost premium to that. So there's easy ones that you can achieve in Alberta right now.
It does sound like there's still this idea of we've always done it this way, and there can be those education challenges or hesitancies to do that. And I guess, Peter, kind of going towards yourself as well, looking at mass timber and wood frame buildings, this is still something that we're kind of seeing as innovative in a sense, and there can be contractors that are even a little bit challenged with going this route and worrying about the constructability of it and the designers and stuff. So I'm really interested in a couple different things. One, in terms of how expensive it can be, how does this help with affordability, not just for the client, but for maybe the end user, especially for looking at things like affordable housing?
Well, I think people are looking at mass timber as sort of the poster child for wood products. But let's be clear, mass timber should not displace light frame construction. Light frame construction has lower embodied energy. It has the ability to be better insulated with less effort because of the cavity fill. It can be just as fast, if not faster, especially if it's off-site constructed. And it's lighter weight, which reduces your foundation costs. Mass timber can be used, in British Columbia, it's now able to be used up to 18 stories. That was announced last week. We have one 18-story building. It's 17 stories of mass timber on a concrete platform, and the structure took 9.5 weeks from the time the concrete platform was started until, the concrete platform was finished, and then 9.5 weeks later the wood structure was done, 18 stories. So that's pretty fast. But there was a cost premium, I think, of about $2 a square foot, but there was a time savings of a few months. But it's not the panacea. It's not necessarily less expensive. Hence, it's not necessarily more affordable, but it can be in certain applications. One of the things that Stephanie talked about, I think if I were to say the word igloo, what would that mean to somebody here? Anybody want to have a guess? Why igloo is relevant to this discussion? It's the only building I know in Canada that's made of a single material. Okay, so whether you use concrete or steel or wood, the question is not, should I build with concrete or steel or wood? It's how do I build with those materials to have the lowest impact, the best cost, the highest performance, functionality, and aesthetics. And that's the challenge. We talked about having one group, whether it's a designer, it could be a code official or contractor, says, I'm uncomfortable with that. I'm uncomfortable with mass timber or wood. That's where the education is really important, to look at what the capabilities and the potentials are. Not, we've always done it this way. We have to reduce the impact of concrete. Every wood building I know of has a concrete foundation. So let's be real. It's not going to be an all wood or all steel or all concrete building. It
ends up being that mixture and the checks and balances that we take a look at in that space as well. And for maybe for people that are a little bit, new to wood and unsure about, using it in specific applications, there may even be people that are wondering, will we run out of wood? Like, were we going to start having to affect our Canadian forests as well to make up for this procurement? So I'd love to hear more about that.
One of the things, most of the wood that is harvested in every place but the Maritimes is owned by us. It's Crown land. Typically, the province determines how much wood you can cut. And just because you might be able to sell more wood doesn't give you any more right to cut any more wood. But what it will do is it will shift where that wood goes. So perhaps instead of sending number 2 wood to the States, maybe a CLT plant or a glulam plant will purchase that. So we don't get any more wood to cut in the forest. That's fixed by the government. What we do with it and how we use it and how well we retain it over time, she talked about, can the building be taken apart? We have to design for prefabrication. We also have to design for disassembly. And when it comes to the ROI on whole life carbon, maybe the design for disassembly is more important than exactly what is the material we're using. So we have to consider that. But as far as if we use mass timber, we're going to run out of wood. Right now, the global capacity for CLT, the poster child, could be met with 15% of 1 year's harvest from British Columbia. Every CLT panel worldwide could be produced by using 15% of 1 year's harvest from BC. It's a drop in the bucket, but it's also the tip of the spear that says, what's possible? How can we do things better and lower carbon?
And where can people find out more information on those statistics specifically? Because I feel like that might be really new to people's ears.
There's a couple of really good groups that have information. One is called naturallywood.com. There's Think Wood. The Canadian Wood Council has a website with a bunch of case studies on it, on heavy and mass timber buildings. In Alberta, we have Alberta Wood Works program. Rory and his team, Rory's over there, is an excellent source. And if they don't have the information, they know who to get it from. FP Innovations is a research group. National Research Council has done all sorts of work on fire. There was a fire demonstration. That information is now coming out and will be really valuable to building and code officials, because that's the big issue for wood, is it burns. And this shows that it burns, but not for very long.
And that pooling of resources is really important, and not to plug CLF Alberta again, but we are hoping to be that resource for Alberta content, where we can have people in the room here and have that information available on our website and through our networking events and events in the future to be able to talk about these, so these things don't seem as crazy and innovative, and they just become the knowledge that we share. Exactly. Yeah. So I guess kind of looking into the future when it comes to embodied carbon, there's innovations that are happening, some digital innovations that may help with reducing embodied carbon, but at the same time, they're also really interesting. One thing that comes to mind in terms of an innovation is 3D printing concrete, which is actually something that's being used right now in a housing initiative in the Siksika Nation. So I'd love to hear more. I know, Chi, if you wanted to talk a little bit more about that and kind of expand further.
Interesting. It's good to see such innovations showing up, and AI is going to take over whether we like it or not. So somehow, sometime it's going to catch up with us. But it's also interesting that from building industry perspective, we're kind of jumping into that. And would it help? Of course, somehow it will, because when 3D printing is going on, the process of making that, the batch mix for the concrete has already been determined, right? The concrete strength and all that. And when the AI or the robot is printing, if there's any waste from that process, those are gonna be collected and also reused in the making of the 3D printing. But one thing I kind of really not sure, which again is a gray area because there's not so much research about 3D printed houses that are made from concrete, is we can't really say for sure what is the quantity of the concrete that is being used. Because if we want to, kind of calculate embodied carbon is actually based on the quantity of product that is used. You multiply that factor by the impact of that material, that gives you the total embodied carbon of products. So if I'm doing 3D printing innovation, that is great. But if I'm using larger quantity of concrete, as I will in a typical concrete structure, that means it will result to higher embodied carbon, right? And if I'm using less concrete and less materials, or using concrete that has more of supplementary materials like SEMs, fly ash, and slag cement in the mixture, yes, of course, it's going to have less embodied carbon because I'm reducing the cement content. So that means it's going to be a positive one. So it all depends on how that mix is, like the constituents of the mix, and how the waste from the construction is being managed.
Excellent, thank you. Stephanie, do you have anything that you wanted to add further to digital innovations at all, or innovations maybe in life cycle assessment and accuracy in terms of those going forward?
Yeah, I think I kind of want to build up on the AI aspect of it, because something we've been looking at internally, as well as advocating for some of our long-term clients that own the building for at least 100 years, is the concept of a material passport, where you actually start embedding a lot of that early stage modeling that she had mentioned. So 50 years from now, you can actually know, is that product still usable to be able to be dismantled? What is all the information? Like, what's the shop drawings? How did it get built? And we're actually piloting something like that on that project that I had mentioned, where we did a whole life carbon, where we have 3,000 sensors we're embedding within the facility to actually track and document all the materials that went into the building, and use it as like a teaching lab, and also to hold ourselves accountable as well if we're actually meeting the targets that we're saying we're doing.
Absolutely. And in terms of, for Peter, is there any innovations that you see in terms of how manufacturers should be dealing with embodied carbon, or how we should be, I guess, talking about it in the public sphere here?
Well, I mean, the manufacturers of wood products are well aware of embodied carbon. I think the whole aspect of boosting our prefabrication capabilities, whether it's modular, whether it's panels, is really important from a material efficiency point of view. Another thing which I think is going to be a more common occurrence is the design of hybrid. I mentioned an igloo, but we don't have to build all of one material. And increasingly, we're seeing buildings that might use glulam beams, CLT floors, a framed back plate, and steel columns, because there's efficiencies in certain uses of certain materials. And I think understanding how to integrate those materials, how to incorporate prefabricated elements that have a low embodied impact, that have insulation and cladding and stuff right on the panel for erection is going to be more common. But it's a difficult hurdle to overcome, because there's only a couple of companies that I know of that have that capacity. I think, and tomorrow, for any of you who may be from Edmonton, AccuBuilt in Edmonton is opening up a new robotics assisted prefab panel company. So that kind of thing we'll see more of. And it's not only an innovation, it's actually an expansion of an existing practice to do more with less. And it moves the dial from focus on price to what are the costs, socioeconomic, what have you, and then looking at values. So the value proposition is where we have to get to. And I think that's part of the transition that we'll do as we try to reduce carbon and increase efficiency.
Absolutely. We're going to do just one more quick question here, and then we'll go to the a bit of a Q&A session. I guess in just terms of looking at the future of LCA, how can we encourage the industry to collaborate with stakeholders, governments, consultants, just so that this is becoming more in the forefront and we actually start making these impacts, to start making changes? Stephanie, would you be able to start off there? How do we get industry to collaborate together?
Yeah, I think it's important to highlight the work that the Treasury Board of Canada is doing, as well as different municipalities across Canada, to start unifying the approach on embodied carbon through Canada. And I think that will help municipalities like within Alberta to see like lessons learned from other jurisdictions that have done it for a few years and start to see like where the gaps are, and in the gaps in the different products, that's an opportunity for like the federal government and the provincial government to provide funds to Canadian manufacturers to understand where are they at and where is there an opportunity for them to optimize their design to lower their embodied carbon.
Absolutely. And we, starting with some of the questions here, we do have questions about case study details on LCA analysis. And I think a big part of that, again, like you're saying, is sharing this information and getting it out there and even learning from our mistakes as well as from our successes. So in terms of case study details, I know, Peter, you had mentioned that there are some resources available on specific resource websites, but are any of you aware of any, or do you have any case studies that you're really proud of that you would like to showcase?
Yeah, if I can. So the Canadian Green Building Council chose the University of Calgary McKimmie Complex, and I think that's a huge testament to Alberta that we were one of the first post-secondary projects in all of Canada to be a pilot project for the zero carbon standard, and they're highlighting all the work that local Alberta companies and consulting firms did to do a significant deep energy retrofit on an existing campus, and going from like 700 of square foot of like carbon down to like 70 per square meter, which is quite significant. And it just shows that you can actually do low carbon development in Alberta, and it's not going to cost you that much more than mainstream construction.
In terms of, we're getting a lot of questions here about existing and new structures. So should asset managers, owners consider LCA for existing construction, or are we saying it's only relevant for new construction? And what is the biggest obstacle to that?
We should. Yeah, we should consider LCA for existing structure, because one thing I noticed when like working in industry, I worked in industry also, like as a sustainability specialist for a while, is when we do LCA for existing, we kind of count all the existing embodied carbon as credit, right? And then we kind of assess the embodied carbon of new materials that are being integrated in that. But in total sense, I think it's important that LCA be conducted for existing structures, especially if we're thinking of it in hierarchy of low, medium, and high impact. If you do an LCA on that, and you know, like, because you're reusing all the existing elements, then we're saving some portion of that is important. But how about the ones we're gonna remove and, you know, dispose? How does that end up? Is that gonna be like, you know, into the landfill, which is really one area that industry is struggling right now, is what happens to all these products, materials, you know, debris from concrete at end of life? Do we really know? Or we just send them there and we're like, yes, we've done our part. Of course, they will take care of it, right? So it's really important that we also think about whatever products is being removed from this building, how do they end up? How are they reused? If they're going to be reused, do they even get recycled at end of life? And what happens to them actually?
And in terms of cost effectiveness too, there's, I guess building a new building is a lot more expensive than just renovation or some type of interior fit outs as well. Are there any government funding that currently exists right now to look at deep energy retrofits or the existing building renovation in that aspect?
I know for some federal ones, but they're very highly competitive.
Peter, I got a question here in terms of the 2030 National Building Code. Do you mean the 2030 National Building Code? The provinces are allowed 4 to 5 years to adopt those. So when will we see this have an impact in Alberta? Do you have any insight into that?
Well, I guess it depends on whether you're lobbying the Alberta government to adopt the 2030 Building Code right away or not. That's, I think there's movement to recognize that energy efficiency, low carbon, is not just it's not so much a hurdle as a benefit down the road. Affordability is going to be a primary driver. That may interfere with the perception that low carbon or high performance is costly. But earlier you talked about case studies, and there's an organization in British Columbia called ZEBEX, Zero Energy Building Center of Excellence, like ENBIX. There was a case study done on a building, it's a 5-story building, light frame construction in Pemberton, which is north of Whistler. It's plus 40 in the summer and minus 30 in the winter. So it's got that full range of climates. And it surpassed passive house energy efficiency and was 10% below the code cost of the day. So we have a step code in British Columbia. Step code 2 was the requirement. It surpassed the requirement for step code 4 and was 10% less cost. And the thing about it was well designed and detailed and well executed. And that attention to execution was critical on the energy efficiency. And so it's possible to do this stuff. That doesn't mean every building is going to be below code. But everything we do has to be intentional, whether it's trying to reduce the embodied carbon, whether it's trying to increase the efficiency, or whether it's trying to drive the cost down. It has to be intentional, and it has to be coordinated. And that's the tough part, but it can be done.
There's a really great question here about adaptation or resiliency into the conversation, as embodied carbon just addresses mitigation. Do any of you have any insight on adaptation and resiliency when it comes to looking at this as part of that conversation as well, in addition to?
Yeah, that's where that whole life carbon analysis comes into place. You can start factoring like the frequency of a 100-year weather event happening a lot more frequent, and that starts to influence what materials you can select for a long-term design service life, as well as what the different operational carbon considerations are. So we're starting to see that with a lot of the design build projects that we're involved with on establishing the baseline that a future proponent will need to take into consideration for building that project.
We have a question here specific that is, says, Stephanie, you mentioned tools and Peter mentioned gaps in data. What would be required to scale up these LCAs for all new buildings, all renovations?
Well, you're going to need data, and you're going to need companies to recognize that, let's say in 2030, you're going to have data. It's going to be enshrined in the code. December 31st, 2029 is not the time to start looking at that. So in our experience in gathering data from trust companies and small mills, they look at this and say, what the heck is this? Why are you asking this information? This is confidential. This is proprietary. Yes, it is confidential, and that's how the information is retained. But you're going to have to divulge your impacts, whether you like it or not. And that has to come across. So the question shouldn't be, you're going to have to do this whether you like it or not. It should also be, so how can we help? So you can smack them on the back of the head, or you can offer out a helping hand. And I think there's guidance that has to be saying, here's where things are going. What difficulties might you have with that? You're an insulation producer. You're a panel producer. You make precast concrete. What are the issues that you face on that? And how do we overcome that? And we've got 5.5 years to do it. So, we can wait till 2029, or we can start now to prepare people to keep track of the data and to start thinking about how they're going to report that data.
Yeah, and then from a consultant side, it's early enough right now that I welcome people to actually look into the tools, because there is a significant disparity in data as well as the accuracy of data within the different tools. Like for us, we advocate for this one tool because we can get quite granular, while there's other tools where they take an average of all of North America, which isn't entirely the best approach, considering that each manufacturer could potentially have a different product category rule when they make their EPD. So it's kind of like the concept of like garbage in, garbage out. It's early now to start looking into those tools. And then my hope is eventually there'll be some sort of API that all these tools will tap into, so we all have the same access to the same data inventory, because that's the other issue too. Depending on which tool you use, they get their data from different locations. So if you do an analysis in one tool and then try it in a different one, you're never going to get the same result.
Just to add on that from a research perspective, talking about using different tools for LCA, yes, your results will vary, right, depending on where they're sourcing their data. And also, it's difficult to really kind of ascertain that if we're going for performance-based specification, because the EPD I'm pulling is the one available. Maybe the manufacturer that I will end up using, they don't have a published EPD, right? So it's still gonna be different, maybe close to what I am looking into, but it's not gonna be as exact as what it is when I conducted the LCA. So usually, like, having people like, manufacturers like Peter has mentioned, kind of willingly, not forcefully, engage in, third-party EPDs, as opposed to having, industry average EPDs is key. Another key thing is also training. There is a lot of skill gaps, right, in industry when it comes to LCA. I think like every architect, every engineer, every designer should, have a little bit of skill to at least understand when you read an LCA graph, to understand like what is the whole life carbon, where are those indicators, where is this impact coming from throughout the life cycle of the building, and what can I do about it? So I feel there's a lot of gap in terms of skill sets that we have in industry right now, and if we all can jump into that and start getting the little training, even if it's reviewing one EPD to understand the products you're specifying, that would go a long way to, making a better decision. Yeah.
Stephanie, I know that we've talked about skills gaps before in terms of, those who are doing LCAs, but as well as the material, like how we're doing takeoffs. For example, using Revit, you may get double counting or missing voids or such like this. So I'm wondering if you have any advice for people who are looking into life cycle assessment, and whether it's going to be part of their own practice or looking into other people to do this for them, but how they might evaluate whether there's like the skills are there essentially.
Yeah, like fortunately there is a lot of free training through like the Canadian Green Building Council, the RAIC, as well as like the webinars that have been hosted previously by CLF Alberta. There's a lot of information for consultants to get that baseline understanding, but there isn't like a requirement for everyone to be expert. That's where like there's specialty consultants like such as yourself, where if you need that added layer of expertise in evaluating different projects and materials, that's where we can leverage consultants like yourself.
We're getting a lot more questions about EPDs here, so I just hope we're okay to maybe focus on that for our last couple questions. In terms of costs for EPDs, especially going from a plant-specific level, like what kind of costs are associated? Do we have an understanding of what that might be like, or that would be quite challenging for multiple product lines as well? Peter, do you have any insight onto costs of EPDs?
Yeah, we're facing that with our data, because we've got, as I say, data from a couple hundred facilities across the country. We're going to have regional EPDs. What is the cost of those EPDs? If you were starting from scratch and you've got a product, and it is one product and one product category rule, then you're looking at about $40,000 to $50,000 per EPD. But if you're doing, let's say you're manufacturing insulation, you're probably going to have a consistent product category rule. So you can do one LCA report that may have 15 different products, in which case the EPD for each product might be $5,000 to $7,000. I think one of the difficulties we face about LCA, there's a lot of really good tools out there. Stephanie talked about some of the whole building LCA and the LCA tools. So they vary with granularity, transparency, ease of use, and assumptions. And the assumptions really can play havoc with your LCA. Do you assume a 60-year building life, an 80-year building life? What's the final disposition of the product? Is it going to get reused, going to recycled? Those are all decisions that we will have to make, or our descendants will have to make in 50 years. So for us, it's really difficult to determine what the end of life is. Was the building designed to be adaptable or climate resilient? But is it also adaptable for flexibility of use? So I think LCAs, they're not nefarious, they're not trying to sort of mess around with your head, but they do because there's so many assumptions that we just can't answer. So we have to be cautious that we're not making unreasonable assumptions about something that's going to happen in the future. But from an EPD point of view, I know the concrete sector has a really good EPD generator tool in the United States. They've generated, I think it's 100,000 plus EPDs, and that's basically the recipe. And there's, so it's a pretty basic tool, but concrete is a series of recipes. So that's a really effective way. They still have to pay to have that EPD produced, but it's much less than the typical 5,000 or for within an LCA report or 30,000.
I'm getting the red light here that we're done, but I actually have one more question I want to throw to everybody really quickly. So we're hearing about embodied carbon. This is another factor we now have to think about in terms of when we're designing buildings and costs and associated, everything from there. Why should we be optimistic about this going forward? I'd love to hear, whoever would love to speak up. Why should we be optimistic about embodied carbon and the work we're doing?
Why would someone be pessimistic about building better? We're going to be trying to design buildings that are longer lasting, more adaptable to our society's needs now and in the future. Lower carbon, high performance, which means lower cost of operating. I don't know why there'd be a downside to that, but maybe that's just me.
Yeah, for me, it's fun. I think it's a challenge, always try and compete against our previous project. And also it's an opportunity for us to conduct R&D and also support the industry of advocating for them to understand where they're at right now in the embodied carbon.
It's great when we get to nerd out about this, hey? Yeah. Chi, I'd love to get your answer as well.
It's important to think about the future generation, right? So we are designing into the future. So if we're designing into the future, it's good that we leave something better for them as we met, right? So that's why I'm optimistic about it. Yeah.
That's great. Well, thank you so much, everybody, for being on this panel today and having this great discussion. I really hope that everybody here in attendance was able to take away something really positive. And there is a networking session, I believe, right after this as well. So there are a couple questions that didn't get answered, so feel free to come up and talk with us so we can try to answer those for you as well. Thank you so much.